In this video, we're going to talk a little bit about exponential growth and specifically some word problems involving exponential growth. So let's suppose that a quantity increases each year by a fixed percentage. Let A be the starting amount and let R be the percentage increase expressed as a decimal. And then after T years, the amount is determined by A times 1 plus R to the T. And if a quantity is decreasing, then we have basically the same formula, except now we have A times 1 minus R to the T. So to see how this works, let's look at a couple examples. First one here, we have a forest covers an area of 1,600 square kilometers. Suppose that each year this area decreases by 8.75%. What will the area be after 5 years? So the first step with any of these problems is once you determine that we're going to be using one of these exponential growth formulas, is you need to determine which one. So since it is decreasing every year, since it is decreasing, okay, that means we are going to use this formula. So we have A times 1 minus R to the T. Okay, so and then now what we need to do is we need to determine our A, our R, and our T. Okay, so first our A. Our A stands for A is for our initial amount, our starting amount. Okay, so our starting amount is a forest covers an area of 1,600 square kilometers. So our starting amount in this problem is going to be 1,600. Okay, all right, and then so then now we need to suppose that each year this area decreases by 8.75%. So our R is going to be equal to 8.75%. But the key here is we need to make sure that our R value is expressed as a decimal. So anytime you're given a percentage, if you want to express it as a decimal, you would just divide this number by 100. So if we divide 8.75 divided by 100, so as a decimal, we get 8.75 divided by 100, and we get 0.0875. Okay, so our R value is going to be 0.0875. And our T value is time in years. And it says here, we want to know what it's going to be after 5 years. So T is going to be 5. So to solve this, we're looking for, so our area is going to be 1 minus 0.0875. And we're going to raise that to the T, which is 5. Okay, so let's bust the calculator out for this one. So we're going to have 1 minus 0.0875, and we're going to raise this to the 5th power. Okay. Oh, sorry, I made a little mistake here when writing this out. I forgot to multiply this by A. Sorry. Our initial amount was 1,600, so 1,600 times this. Sorry about that. So that's going to give us 1,012. So if we round it, we're going to have 1,012 kilometers squared as our final amount. Okay, so after 5 years, this forest is going to go from 1,600 square kilometers to 1,012 square kilometers. All right, so let's take a look at this one. Let's say we have a principal. A principal just means an initial investment. So this is how much we're initially investing right up front. A principal of $2,700 is invested at 3.5% interest, and it's compounded annually. Okay, so we're going to talk a little bit more about compound interest here in a little bit, but right now just think of this as just a basic exponential growth problem. It says, how much will the investment be worth after 6 years? Okay, so let's go ahead and find our A, R, and T. All right, so our A is our initial amount, which we said was $2,700. So we'll say $2,700 for A. All right, so our rate is R, okay? So this is going to be 3.5 divided by 100, because remember, we have to express this as a decimal, okay? So 3.5 divided by 100 is going to give us 0.035. Okay? And then our t is time in years, which we said was 6. So that means that our investment will be worth, so if we do A, so we'll have 2,700 times. And remember, okay, sorry, I didn't clarify this at the beginning. We're growing, investing. Typically, at least the goal is you want your money to grow with an investment. So if the interest is compounding annual at 3.5%, it's going to grow. So we're actually going to use this top formula here. Okay, so we'll have 1 plus 0.035. All right, and then we're going to raise this to the t, which we said was 6. Okay, so let's go ahead and type this into a calculator. Okay. And if we type this into a calculator, we're going to end up with, once we round it, we're going to end up with $3,319. Okay, so that is going to be our final amount once we let our investment grow for 6 years without touching it. So if you invested $2,700 now at 3.5% interest and you just forgot about it, 6 years later you would be at a little over $3,300. So there you go. Let your money do your work for you, I guess. All right, so in our next video, we're going to talk about the compound interest formula specifically, which is kind of an extension of this formula we're using here.